My name is Fred Morris. I'm the Bruker Optics product manager for our new Lumos FTIR microscope. It's the latest product from Bruker Optics and really the most state-of-the-art FTIR microscope we've brought to market. The system obviously is a completely self-contained unit. As you can see, there's no knobs, there's no devices to change any apertures, change objectives, or anything like that. It's a completely standalone system. So you have integrated source, integrated interferometer, integrated detector, and full automation. And when I say full automation, I mean everything from XYZ sample stage to automated apertures to automatic change of the numerical aperture between the vis and the infrared, along with automated ATR. So you can see the large open concept we have here, which means that you have a lot of working distance for a lot of different types of samples, whether they're small, whether they're large, and it really enables the user to bring the sample stage out without having to get into the microscope and use tweezers to really place their samples, really place the products there. You have a lot of open access, and then when the customer's ready, all you do is you just bring the stage up and you're ready to do your sample analysis. So what I can show you next is maybe just a typical ATR sample that any customer would do for maybe defect contamination or defect analysis, particle identification, surface analysis, the typical FTIR microscope samples. So if we look, we can see our screen here, and we're able to just simply click on a spot and move to that spot with our automated X, Y, and Z stage. So here I've just moved to my lovely Bruker sticker that I have. I can take a single snapshot, and you can see it's a nice high resolution 5 megapixel digital camera that takes that snapshot. Another really unique feature is their ability to automatically zoom into a particular area. So for instance, if you do have a 5 micron particle over here, you can just click the stage, it will move to that area, and then I can just activate my 32x digital zoom, and it zooms in right away so that you can get another picture of your particle. By deactivating the zoom and building a larger image, I'm able to click on this, add border points, and then I'm able to collect a larger image. And this could be really useful for looking at different particles, different areas of analysis on the sample. By building a large image, you're able to really kind of hone in on maybe what this little particle is here. This looks like a fiber, probably from my jacket over the course of the day. But you can see the stage automatically moves to all those individual positions, building us a nice large mosaic sample. The level of automation on the Lumos is really, there's nothing like it on the market. It's really kind of gone beyond anything that is commercially offered. So it's something Bruker's really excited about. So now again, within our software package, we have our live image and we have our static image. And just by clicking move to different positions, you can see that I can click on my static image and go anywhere and ready to start my sample analysis. So just by clicking through the wizard, and what the wizard is it really is an interactive software package that guides the user from visually collecting their sample to taking a background and then to taking their sample analysis. So what I'm going to do is I'm going to simply go ahead and I'm going to take an ATR sample spectrum. And what ATR does is it literally comes down and it literally touches the sample spot, and that's how you get your infrared analysis. So as you can see, when I went to take my background, the stage lowers automatically, and you can see one of the biggest unique features about the Lumos is the automated ATR. That ATR objective is just like an anvil. That spot is about 100 microns in diameter, so the infrared beam clips it and we're able to take our background completely automated. Even the aperture blades within the Lumos are automated, so if you're going to aperture down to say 10 by 10 microns, 20 by 20, or even 5 by 5, the aperture blades know based on the aperture area that you design. So our background's complete, and now we're able to go ahead and take our analysis area. So what I'm going to do is I'm going to do a couple spots, but I could do everything from a grid, drawing a large grid, and doing mapping of individual areas. I could also do a line map, or I can do a spot-by-spot analysis, which is what I'm going to do. But you can see I can also switch between the different pictures I collected previously, and all of these pictures are saved with my spectra. So what I'm really interested in doing is I want to see if there's a difference between my blue ink, my black ink, or no ink. So what I'll do is I'll take individual spots, here, here, and here, say next, name my sample, name the number of scans I want to do, and go ahead and click measure. So now the Lumos is automatically going to take a new background based on the aperture I chose, and you can see the aperture blades close into a position. And again, the amount of automation in the system is really the most unique, and it's one of the most important parts of the Lumos. But all the automation doesn't really close down the fact that it's actually a really high performance system. We've marketed this to the routine customer because of the ease of the use of the software, but also to our research-based customers because of the high performance spectra that you're able to achieve. You really get the best of both worlds with this system. So I mentioned that we have the automated ATR, we have automated condenser, automated polarizers, automated XYZ stage, and the other thing is we have the automated numerical aperture change. So in your standard visible microscope, you want a low numerical aperture in order to get the best visible focus on your sample. But then when you take an infrared spectrum, you actually want to collect a higher numerical aperture to be able to collect all of the scatter that's coming off your sample. So in the Lumos, what actually happens in an automated fashion is we collect the visible image under a 0.4 numerical aperture, and then when you switch to the infrared, it automatically switches to a 0.6 numerical aperture. And again, what this does is it gives you the best of both worlds, the best visible clarity that you can get and the best infrared data that you can collect. Our analysis is done. And now we're able to look at the three distinct peaks that our blue, our black, and our white paper are able to give us. And you can see the beautiful specificity that our blue, black, white ink give. We have tremendous signal to noise. And if we were able to collect a larger map, say something like this guy here, we would be able to integrate over a larger area. And here you can see the high concentration of our different chemical regions. So you're able to actually get chemical mapping by doing larger areas with lower spatial resolution.